on the test. 5 different kinds. So let's see what we got first on this practice test. Oh, domain, our favorite. Okay, so this one is set up just like the test. It's got answer blanks and everything. So here we go. Tell me what you know about domain. What is under the radical has to be greater than or equal to 0. Okay? So as I'm writing these down, I've got a couple of radicals here. So I'm going to make sure that what is under them, so this guy right here, so x minus 4 is greater than or equal to 0, so x is greater than or equal to 4. And then I saw one right here, x plus 5 is greater than or equal to 0, so x is greater than or equal to negative 5. All right, that takes care of radicals. Now, what's the other rule? Denominator. So, denominator cannot be 0, so x cannot be 6. So, problem 1, or problem A, has 2 parts. Alright. Oh, this one has a denominator, so x plus 7 cannot be 0. So x can't be negative 7. So here's the 2-part answer to A. Here's the answer to C and D. What about B?
All reals.
All reals, which we write as negative infinity to infinity. Everybody good with that? That's part 1. Okay, part 2. Find the asymptotes and holes. So let's look at A. And what did I suggest to you what we should always do with these problems if we can? Factor. So the top does not factor, but what about the bottom? So let's go ahead and factor the bottom. How does it factor? Minus 4 plus 1. Now sometimes when we do that, we cancel. Not this time, which means down here we're going to write the word none. Do not leave it blank. Do not put a 0. Write none. Or don't have any. Or something. Now, what about vertical asymptotes? This is my problem now. This is it right here. What about vertical asymptotes? Where do they come from? Well, they're linked to domain. They come from the denominator. So in this case, look here. What's going to happen? There's 2. There's 2 of them. My vertical asymptotes are x equals 4 and x equals negative 1. Because both of those would make the denominator 0, and that isn't allowed. Agreed? Perfect. All right, what about a horizontal asymptote? What's wrong with this situation? There's no x squared on the top, so I got to put a 0 up there, and now I have 0 over something?
Yes.
What's 0 over something?
0.
0. Y equals 0. And there you go. There you go. All right, next time I see you, we have a test. So if I just did something that you're not sure about, this is the time to ask, right? I mean, we do have office hours tomorrow, too.
So we
You revert back to the original problem when you had to add the 0?
Yeah, yeah, because then I could see the x squared. Okay, all right, here we go. Next one, what do you think we ought to do here?
Factor.
Factor it, okay. How does the top factor?
X plus 5 and X plus 1.
No,
Oh,
need 2 and 3, because they have to multiply to give me 6,
yeah.
right?
Yeah, I thought it was, yeah.
And how about the bottom? They have to multiply to give me negative 15.
We are.
Minus 5 plus 3, very, very good.
They cancel out. Oh, that's a whole.
Does everybody notice?
Yeah.
We can cancel?
Yeah.
So the equation that I'm going to graph is actually y equals x plus 2 over x minus 5. But because I cancel, this one will have a hole. Now the hole is a point. You need an x and a y. Okay? So where is the x coming from?
What you cancel?
What you cancel. Since that's in parentheses, it's going to be negative 3. So my hole is where x is negative 3. And then how do I find the y part?
Plug it in.
Plug it in right here. So I have negative 3 plus 2 over negative 3 minus 5. Negative 1 and negative 8, which is 1/8. You will have your calculator to help you with arithmetic if you need it. All right, remember, this is our problem here after we cancel. This is what we've got. Do we have any vertical asymptotes?
Yeah.
We have one, and it's where x equals 5. How about a horizontal?
1.
Y equals 1. Now, with the horizontal, that kind of back to Jose's point, could I have looked at the original problem and gotten 1? Yeah, doesn't matter. Look at whatever's easiest for you. For the horizontal, it doesn't matter.
How did you find?
Denominator cannot be 0.
Okay.
Okay, it's time to wake up here, dude. All right. C, one more of these. C. Can I factor anything here? Yep, I absolutely can. Is anything going to cancel? No. But I think factoring does help me a little bit in this problem, because even though nothing cancels, can I now at least tell where my vertical asymptotes are going to be? Ready?
If you like say like how the vertical or how you got -3 for like the point in the hole, could you plug it into the original
No.
problem?
No, it has to be the reduced one. Because if you try to plug it in the original, you're going to get a 0 at the bottom, so you won't get an answer. Always plug it back into the new equation. Okay, so what are my verticals here? What x is either -1 or 1? 2 vertical asymptotes. Every x in the denominator is going to give you a vertical asymptote. No holes, because we said nothing canceled. How about horizontal asymptote? Y equals 1. Okay, so that part's done, that part. So the test, remember, we got a domain part, we got an asymptote part. What's next? The sketching part. Now we're going to sketch. You will notice, those of you that looked at your homework, what am I really, really big on in terms of grading those graphs? What do I need to see? The labels.
Label.
Gotta see the labels. If you are moving your picture, you have to tell me where you put it. Alright, so here's this first one. This one is worth 4 points on the test because it's got more parts to it. Okay? So here we go. One part at a time. You're welcome to use colors tomorrow if that helps you. You don't have to, but if it helps you, you can. All right, what is that x squared? What shape is that? That's a parabola, and I didn't move it, so it's vertex at the origin. Right? Here's where it crosses my breaking point.
Closed.
Closed in this time. And I've broken my parabola, I'm throwing part of it away. I'm keeping part of it. I'm keeping the right side, look where that arrow's pointing, which means I'll get rid of this. What's this? Identity line, but it has been dropped down 1. So I'm gonna have my regular old line, hopefully straight, but it has been dropped down 1 unit. Here's my dot. And don't be afraid to make your dots big. Go ahead and make them big so it's clear. This is my dot. This time it'll be open. And I am going to keep this little arrow part and get rid of all of this. Now, I'm going to go ahead and erase my squiggly. You do not have to. If you want to leave your squiggly line in there, you can. I think it makes my picture look a little cleaner without it. But that's it. We good? People? Now we've got a bunch of smaller graphs. Remember, f of x and y are the same thing. So whether it says y or f of x is irrelevant. That doesn't matter. What shape we got here? Parabola. How has it been moved? Right, 1, and up 2. So right 1, up 2, label that point, draw your parabola, done.
What's the square has nothing to do with it?
That makes it a parabola.
Oh, yeah.
That's how you know it's a parabola.
You gotta know shapes.
All right, next. What's this one? Absolute value, which means it's going to be a V. What has happened to the V? This goes up 1. What about this one? Left 1. Remember, every number has an impact. So pay attention to all the numbers. So we're going left 1 and up 1. So that's this point right here. And it's a V. Okay. Yeah, just want to make sure I can see over there. Okay, so what's happening here? What's happening to this picture?
Exponential, it's moved up to.
Up 2. Okay, so this is one. This is, some of these curves are harder for me than others, and this is one that's a little bit harder. So I'm gonna get over to the side, I'm gonna sketch my BFF. There's an asymptote here, and a dot at 0, 1, and then a curve that looks like that. Would everybody agree? That's my standard. Now, you said I'm going up 2. That means that the asymptote is now going to be at 2 because it wasn't 0. And the point is now going to be at 3. And there it is. Same shape, everything moved up 2.
Oh. Yeah.
Here's another one that's kind of tricky for me, so I'm going to draw it standard before I do it. What's that going to do? Down 2. Okay, so I'm going to go ahead and draw my regular cosine. Here's my regular. Now I'm going to bring everything down 2. So see this point right here, that's at 1. That's normally at 1. So if it comes down 2, would you agree now it's going to be at -1?
Yeah.
Now, that point is still the top of the hill, right? So from that point now, there's my hill, and then I'm going to do my valley. See how it's exactly the same shape, you guys? Just everything came down 2. It was like I cut this out and pasted it down here. Oh no. This is 4, it must have been, I don't know what's going on here. I don't know, wild and wacky. What's different about that?
It's negative.
It's got a negative out there in front. We talked about this last year. Anybody have any, well, let's just stop. Let's pretend for a second the negative isn't there. It's gonna go right to, and it's the square root function, so it looks like that. Okay, that is this. Now, our real one does have a negative in front of it. Does anybody remember what that does to the picture? Kaylee? You are almost there. Negatives cause things to flip around. But a negative out in front like this, Kaylee, actually makes us go upside down. So not left to right. There is a negative that would go left to right. This one outside the problem goes up and down. You know how it matters whether the number is inside or outside? Negatives matter too. So if it's outside, it's upside down. So we're gonna have that same picture, but instead of going up and out, it's gonna go down and out. So a negative out in front is an upside down. I promise I won't put any fancier negatives anywhere else, okay? If there's a negative out in front, whatever you drew, turn it upside down. And I promise I'm not gonna give you a crazy thing like that or something, okay? Okay, so that's the second, or third, that's the third part of the test. All right, so what have we done so far? We've done domain, asymptotes, and sketching. So now we have the function part. All right, look at problem A. Girls, if you're talking about math, that's okay, but all this crap is being picked up by the iPad, and that makes it hard for other kids to watch it, okay? So, shh, unless you're discussing math. All right, P of X times Q of X. Just multiplying, right? So that's gonna be a distributive situation. So when I multiply these two, I'm gonna get a negative 6x cubed plus 2x squared. And that's all there is to it, guys. That's it. How about B? What does B want me to do? Plug the P equation into the X in Q. Perfect. Perfect, Owen. That's exactly right. So here's my P equation, and I'm gonna plug it in right here into Q. So we're physically taking P, the whole P, and putting it into Q. So what will we have? Negative 3, 2x squared, plus 1, which is negative 6x squared, plus 1. Joseph, are you okay? Do you need to go to the nursery? Okay. All right, so that's what I get. So whatever, when it's written this way, take the inside one, whatever that function is, take the whole thing and plug it into the other function. Everybody got it? All right, so what's happening in C?
The extra P is 2 and the extra Q is -1.
So we're gonna take 2 and plug it into P. Oh, here's another one, guys. Please be careful. Please be careful. What do I do first here? 2 squared, right? 2 squared is 4 times 2 is 8. You see, if you do that wrong, you're gonna get the wrong answer.
Yeah, I totally did that wrong.
Because if you do 2 times 2 and then square it, you're gonna get a different number. So, remember PEMDAS, 2 squared times 2, so that's 8. How about this one, Q of -1? So I'm gonna put it right there, so that's gonna be -3 times -1 plus 1,
So it's just 4.
4. And then in this problem, it says atom,
So it's 12.
so the answer is 12. So we're gonna find P of 2, we're gonna find Q of -1, and then we're gonna add them together because that's what the problem says. Last one, this section. What is P of Q of 0? Okay, what do we do first? 0 into Q. So Q of 0. So put a 0 right here. What do we get?
0.
And then add 1.
1.
So we get 1. -3 times 0 plus 1. Now take the 1 and plug it into
2.
P. And again, do it right. 2 times 1 squared. First thing I do is square 1.
2.
And then times by 2. So that would be the answer.
3.
Oh, two,
Okay? One more section, and it's the easiest one. Find the implicit functions. What does that mean I'm supposed to do if I'm gonna find the implicit functions?
Oh, you're gonna just get raw by itself?
I'm gonna get y by itself, so I need to rearrange this equation so y is by itself. So maybe I'll subtract x squared. Oops, Would everybody agree with that? Of a negative y squared then equal to 25 minus x squared? I'm not by myself yet. What do I need to do?
Square.
No, divide by -1. And dividing by -1 is a simple simplification that you need to make. So we'll have a -25 and a positive x squared. Would you agree with that?
Yeah.
You may have it written as x squared minus 25. That's the same thing. It doesn't make a bit of difference. Okay? Now what do we do?
Square root.
Square root. Either one, but rather either one. So y equals the square root of x squared minus 25 and the negative square root of x squared minus 25. What you write in that answer blank is exactly the same, except one has a negative in front of it. Otherwise, they are identical. We are going to fight the temptation. Some of you are going to see this and say, oh, square root. No, you can't because of the minus. This is the answer.
Because the
It's gonna
minus
stick
inside.
if I have to take off points because you got crazy.
Is it the whole question that you got wrong? Is that what you want to mark it as?
Now, wait
The
a
whole
minute.
question?
This isn't fair. What's this number 6 on there? We never did anything like this. What is it doing on here? Well, I don't know, but my guess is
Math.
that if the teacher is gonna throw in at the last minute some wacky problem, it might be a bonus, maybe. All right, so I'm gonna do one. I'm gonna do this one and this one only. Okay, so I want you to think back to the problem we just did where it was Q of P of X. Remember that problem, Q of P of X? And you told me that the way to do that is to take P and plug it into Q, right? So in other words, the first function we did anything with was P.
Yeah.
And then we took that, whatever it was, and plugged it into Q. So in this problem, whatever happened, we plugged N into M. Agreed? So N is going to be the first function I use. I'm going to figure out what N is. And then I'm going to plug it into whatever M is. So this is my first, this is my second. The way that's written. Now, I want you to look at this problem. There are two things happening in this problem. If I said plug in 5, what is the first thing you would do to 5? Multiply it by 3. And then the second thing you would do is subtract 7.
Oh.
So the first function is the function that times us by 3. That's 3x. That's the first function. It takes whatever you feed it, an x value, and times it by 3. Now what does the second function do? Subtract 7. Now here's where we get messed up if we're not careful. Whatever you feed it, minus 7. So this function does not times by 3. The first function times is by 3. The second function subtracts 7.
That's it?
That's it.
Oh.
And that's all I'm doing. I'm not talking about that anymore.
That's pretty.
You need to spend time on that if you think you're gonna do that problem. But you don't have to do that. It's easy. It's super easy. Okay, so what I want to do now is any problem you would like to do for extra practice or a homework question, you've gotten back all the homework, whatever you turned in, you got back, except for today's. Anybody There's 5 kinds of problems on the test. Anybody have a question about one of those 5? Or have a homework question? Okay, guys. You've known me for a month or so. How many days have we stopped?
Never.
Never. Not gonna happen today either. So you're either gonna ask me what you need to ask me, or I'm gonna start blabbing. Okay, because we're gonna fill this time with review, because by golly, I'm not spending my Thursday night grading a bunch of bad papers. These papers are gonna be good. Okay, so here we go. Tricks?
Can we do one that's like number 4 on the first page?
On which practice test?
Practice test 1.
Practice test 1, like number 4, so like a piecewise function?
Yeah.
Yep. So we're gonna graph a piecewise function. Everybody get out a sheet of paper and do it with me, please. Or if you have room somewhere on something you've already done, like on your practice test, that's fine. All right, so here's our piecewise function. X squared plus 1, absolute value.
Looks like you'd be a businessman. With a suit.
With some classy shoes.
Yeah.
What?
And the
And a
office.
belt.
And
Okay.
hair like that.
So here we go, Evan, got a problem. Here it is. This right here is what shape? Oops, let me put my squiggly in, my squiggly is 1. Okay, what shape is that?
Square.
So which means it's a
Parabola.
parabola that has been moved up 1. So here is my parabola. Here is my dot, which is a solid dot. Now, Evan, are you with me so far? Now it's time to erase. I'm gonna keep that, so I'm gonna erase all of this. So far, that's what I got. Now, I got crazy on this second one. What's this gonna be?
Upside down.
And
Like,
now it's a V, but it's gonna be upside down, because I popped this negative out in front of it. So I didn't move it, I just flipped it upside down. So it's going to look like this. It intersects right there. Open dot. Gonna keep all of this, so get rid of this. And then I'll go ahead and erase my squiggle, but you do not need to. And there it is. Evan, you okay with that? All right, who else has something?
I would like to see another one of those.
All right, we'll do one more. All right, so here we go. Here's our piecewise function. We need to graph this. Okay. Oh wait, my squiggly is at 1 again. All right, what's that look like?
the square root is
Square root,
left 2.
left 2, not moved, I mean not picked up or down, just moved left 2. So it's gonna look like that. And it intersected, or got broken right there. Solid dot. Keep this part.
Yeah.
So get rid of this part over here.
Forever.
Alright, what's this? What shape is this?
Parabola.
Parabola that has been moved down to. It intersects here. Open circle. Get rid of this side because the arrow is pointing left. So that's what I keep. And that's it.
Can we by chance go over one of the
Just wait a
horizontal?
second.
Sorry,
So, Jose, you got this now?
Yes. Slightly more, yes.
One piece at a time. It's easy. Okay, so asymptote problem?
Yeah,
Alright.
but can we specifically do one that requires factoring because it's like,
Alright, so let's try an asymptote problem. So.
Oh, you got robbed, dude.
Don't care, I got my stuff back immediately. Yeah, anyways.
I'm playing.
Just like your draw shit.
Alright, here we go. Question says, what are the vertical, horizontal, and holes? Are there any of those that you can just fill in right now at this moment?
the
No.
horizontal is.
Actually, there is. You can do your horizontal, can't you?
Yeah.
So if you want to do that one, boom, and not worry about making a mistake with factoring or whatever, you can. That is going to be y equals 2. You can do that. You don't have to. I'm not saying you have to, but I'm saying you can. Do it right now. Everything else, we're going to have to do some factoring. So look at it. What do you think about factoring the top? Take out a GCF. If I take out a 2, I'm going to be left with x squared minus 16, which is x plus 4, x minus 4. What about the bottom?
The cruise is prime.
Wanna be 4 and 2.
Minus 4 minus 2. Uh-oh.
Cross out.
We can cancel out.
Which means we have a hole.
Yes. Which means we're gonna have a hole in this problem. Remember, they only happen when you cancel. Okay. So where's that hole gonna be? Find the x first. The x is gonna be at positive 4.
Yeah.
And the y will be at 2 times 4 plus 4 over 4 minus 2,
12 over 6.
which is 4 plus 4 is 8 times 2 is 16 over 2, 8,
4 8.
4, 8. And what about a vertical asymptote?
X equals 2.
Two.
Comes from the denominator,
Yeah.
x equals 2. Okay, so this problem had a hole, okay. Sometimes we factor and they don't have any holes, right? So you just write none. What is something else kind of tricky we have to remember in this section of the test with the asymptotes and all that? We have to remember the whole 0 thing, right? That impacts your horizontal asymptote. So if you had a problem like 2x squared over 5x minus 3 over x plus 7, where would your horizontal asymptote be? None. Because wouldn't you have to put the 0 in the denominator?
Yes.
And when you put a 0 in the denominator, that is always bad news. No good. If that were upside down and it was something like this, then you would put your squared on the top, or your 0 on the top, and that would mean the asymptote was at y equals 0. Okay, Kaylin?
Video will show.
Will any of the, f of g times x problems be on the test?
Yeah, I'll put question.
Yes, I mean, everything on the practice test, yes. So you wanna do a function problem?
Yeah, but like f of g in one parenthesis and then times x. Is that the pause problems?
Oh, yeah, that's the same thing, remember, this notation is exactly the same as this notation. It is the same problem. So these mean the same thing. We talked about, this means take g and plug it, the whole g function, and plug it into f. That's exactly what this means. Take the whole g function and plug it into f. It's two notations, but same problem. Okay. All right, what else? Okay, so now I need some volunteers. I'm gonna make you come up to the board. All right, so I want somebody to come up and sketch this,
I can do that one.
and I want somebody else to come up and sketch this one. Okay, let's go. Volunteers. Good. Use the black markers, please. They show up better in the video. All right, what are the rest of you doing? Aiden, that is not what we're doing. We're not stretching our neck. We're stretching our brain right now. Okay? We're all doing these two problems. And then I'm gonna grade the boys at the board, and we're gonna find out how well y'all did. Make sure whatever you are drawing, that you are labeling your starting point.
You good?
All right, let's take a look at what's happening here. Thank you, man, for volunteering. It takes guts to do that, and I appreciate it very, very much. All right, let's take a look at this one. First of all, does he have the shape right? Square root, right? Square root. Has he moved it correctly? Left 1, down 3. He labeled that point -1, -3, and up and out. Everybody good?
Yeah.
A+, perfect.
Not mine.
You had a tougher problem, Keith.
Yeah.
You had a tough problem. Let's look at what the original sign looks like. There's my dot at the origin. Hill, and then valley. And then backwards over here. Okay? This is what it has to look like. So as I am looking at his paper, the first thing I notice is he has hill, or something, I'm not sure, right? So I think there's something wrong with that picture. Let's try again. Good try, partial credit. Good try. Where's my new starting point? My starting point used to be the origin, but now it's been moved up 1, which is exactly where he has it. But the starting point is not the bottom of a valley. At the starting point, we draw a hill and then a valley. valley, and then hill. There is your picture. All right, so let's talk about that to make sure we don't make, I would bet my salary, which isn't that much, but I would bet my salary that a lot of you mess this up. This is a hard one. So let's go through it again. Here's the dot. This dot right here comes up 1. There it is, 0, 1. Remember that with the sine curve, from your starting point, you draw a hill. So I drew a hill. And then I tack on a valley. Does that make sense to everybody?
Yeah.
Okay, so that's what it looks like.
Does it have to touch the x-axis?
It technically does, but I haven't, we're gonna, when we get to trigonometry, we're gonna be graphing sines and cosines much more carefully. So as long as you have something that looks like this, I'm gonna be okay with that. Okay? All right, 2 more volunteers and then we'll be done. Here we go. Come on, you chicken livers, let's go.
Caught you a chicken liver. I'll buy you things.
That was so late. You're late for it.
Oh, that was easy, bro.
You got it.
That's how he talks.
Oh, yeah, I'm gonna do
Mine really-
Okay, here we go. Here are our problems. Let's go. Everybody's doing this, so you're gonna make me mad. You're not gonna make the teacher mad right before test day.
Well, other than bro, I can't see you.
No, Jose's got a domain problem. Evan has one of those P of Q of X problems,
Yeah, right.
function problem.
Do it by yourself.
Can somebody help Evan? He's stalled. Get up there. Get up there, help him.
Oh, me?
Sure. Why not you?
Well, Jose's,
Okay, that's a dangerous thought. Come on, there's a
I
get up
don't
there.
know.
Hey.
I grade is Jose's on that.
Hey, Jose.
What were you
Bring up your son.
That one.
Bring up your son.
You need to stay up here, Evan, because she's gonna talk to you about what she's
Pants
doing.
down.
You have to plug this in for P's X.
So, did you hear what Lizzie said? Q goes in for P's X,
Yeah.
which is exactly what happens. Q goes in for P's X.
Oh, nice.
Yes, you were.
Don't say it like that.
That's your real friend.
Okay, let's take a look at these and see what we've got here real quick. Is Jose's correct?
Yeah.
He said his domain was this and this, he has both parts, correct? Okay, we finally over here, we took Q and plugged it into P. That looks perfect to me, how's that look to you? Alright, so here's what I want just to say, and I value my volunteers, thank you so much for being willing to volunteer. But I put 4 problems on the board, and you missed 2 of them. That's half, right? So maybe we think we've got this under control, but we probably need to go back and do one of the practice tests all by ourselves.
Yeah.
They're in Schoology, do it by yourself. Use the video, the one we did in class to help you. But you must practice. Because